We're looking at chemical combination, and it talks about two or more atoms of element combining to form a compound. Now, the rare gases have a very stable structure owing to the electronic configuration, which confers on them the duplex and the octet structure. Every other element in nature, apart from the rare gases, in an attempt to attain this duplex and octet structure, goes into chemical combination. The duplex structure has 2 electrons as maximum number of electrons in the first share or the K share, while the octet structure has 8 electrons in the second share, third share, as far as is the atomos share. Outside the fourth share, the octet configuration gives 8 electrons as the maximum number of electrons in the atomos share. This confers stability on any element or compound. And this is what every other element is trying to do. Types of chemical combination. We have 2 main types of chemical combination. There is electrovalent or ionic combination, and then covalent combination, which can be subdivided into ordinary covalent combination and coordinate covalent combination. Let's look at electrovalent combination for the sake of this discussion. What is electrovalent combination? In electrovalent combination, it involves the transfer of electron from one atom to another. The atom that transfers the electron is called the electron donor and is usually a metal, while the atom that accepts the electron is called the electron acceptor and is usually a non-metal. When a metal donates an electron, it forms a positive ion, while when a non-metal accepts an electron, it forms a negative ion. Elements which atoms have 1 or 2 valence electrons require less energy to give away this electron. The ease in releasing this electron is in order to attain the stable duplex or octet structure that make them very reactive. Such elements readily combine with many other elements and compounds in their environment to form what? Compounds. Examples are the alkali metals such as what? Lithium, sodium, and then the alkaline elements such as what? Calcium. Each of the atoms has only, like the alkali metal, each of the atoms has only 1 electron in the atomos share. Like lithium now, the first share will take 2 electrons with 1 electron in the atomos share. So it will find it easy to give her just this 1 electron instead of looking for 7 to what? Attain the octet structure. It will rather maintain the duplex structure and be stable. Sodium, with atomic number 11, we have 1 electron in the atomos share. It will prefer to give out this 1 instead of looking for 7 to attain octet structure. It gives us the 1, fall back to the octet structure in the inner core. Calcium has 2 electrons in the atomos share. So instead of looking for 6 electrons to attain the octet structure in the 4th share, it will give out the 2 electrons and fall back to the octet structure in the 3rd share. Okay, fluorine has 7 electrons in the atomos share as shown. So instead of giving out this 7 electrons, the energy it will need to give out this 7 will be too much. So chlorine will rather accept 1 electron and attain an octet structure. So when it accepts this 1 electron, it becomes fluorine 1 minus. Chlorine 17 will have 7 electrons in the atomos share. It will equally prefer to accept 1 electron instead of gathering momentum to release what? 7 electrons in order to attain the octet structure. It accepts 1 and then it is stable. And then it will also become chlorine minus because it has accepted 1. Chlorine minus means it has accepted 1 electron. Oxygen is 6. It has 6 electrons in the atomos share. So it will prefer to accept 2 to form a stable structure instead of giving out the 6. So because it accepts 2 to attain the octet structure, it will become what? O2 minus. So in all of this is what happens. If you have less than 4 electrons, you prefer to give out 2 electrons. If you have more than 4 electrons, you prefer to accept what? Electrons. After metals donate the electron, metals become positively charged. As shown, sodium has given out 1 electron, it becomes sodium plus. Why not metals become negatively charged? As shown, chlorine accepts 1 electron and it becomes what? Negatively charged. So also, potassium will become positively charged, calcium will become positively charged, aluminum will become positively charged, oxygen will become negatively charged. Let's look at an example of an electrovalent combination. An example is the formation of sodium chloride. Before reaction, sodium has atomic number of 11, it will form it has the configuration 2,8,1. That is 2 electrons in the first shell, 8 in the second shell, and 1 in the last shell. Chlorine 17 will be 2,8,7. After reaction, sodium will give out 1 electron and it will fall back to the octet structure, so it will become only 2,2. That is sodium ion. And chlorine will accept 1. And so the third shell, instead of being 7 now, will now become 8 because it has accepted what? 1 electron. Let's look at the equation of the reaction. Sodium, like we say, give out 1 electron, it becomes sodium plus. Chlorine will accept 1 electron, it becomes chlorine minus. If you combine these two, you're going to have, if you add equation 1 and 2 together, you're going to have sodium plus chlorine plus the electron sodium donated and accepted by chlorine. And so it will become sodium plus chlorine minus plus what? Electron. Energy can neither be created nor destroyed. So we're going to have sodium plus chlorine will form sodium ion plus chlorine ion. And this is how electrovalent compounds are. For diagrammatically, if you represent this using the electronic configuration diagrammatically, you see that the sodium has 1 electron in the outermost shell. That is electronic configuration 2,8,1. It's going to be the electron donor because you find it easier to give out this 1 electron. While chlorine, on the other hand, has 7 electrons in the outermost shell. And so because of that, it will prefer to accept 1 electron to attain the octet structure in the third shell, while sodium will give out 1 and fall back to the second shell to become what? Stable. So, as can be seen, sodium now will have 2 electrons in the first shell, and now the second shell will have only 8 electrons. And there will be no third shell again because it has given out the 1 electron. And this now is a configuration for what? Sodium ion. You can see it has 8 electrons now in the outermost shell. So we're going to have sodium ion, which is going to be 2,8. While for chlorine ion, the sodium atom has donated 1 electron to the chlorine atom. So we're going to have 8 electrons in the third shell of chlorine as against what the initial 7 that chlorine has. So because of that now, chlorine ion has been forming, it has accepted an electron to become what? Negative. So it's going to be 2,8, meaning that it has attained its stable structure. So this is how you can represent electrovalent compound diagrammatically. There is going to be definitely an electron donor and they have to be what? An electron acceptor. The metal is always the electron donor, while the non-metal is the electron what? Acceptor. Properties of electrovalent compounds. 1, they have high melting and boiling point. They are readily dissolved in water. They are very good electrolytes. Anyway, anytime, this is their property. If this is your first time on this channel, and if you like this video, please do not forget to subscribe, like, comment, and share.